And then, ano na lang. So, let me call you mathletes because we are the,
The Mathematics Society.
we belong to the Mathematics Society. Or, so, we are gathered here as one today with only one purpose. That is to learn, of course. So, before anything else, we are inviting everyone to please rise for the prayer, followed by the recitation of the vision mission statement to be led to us by Mr. Charles Maramo.
Let us stand together. Let us pray in the name of God, and the Son, and the Holy Spirit. God,
You are the most powerful, here on earth and in heaven. We thank you for the love that you equally divided unto us. For giving us
Another chance to follow
for helping us to find the solution of our problems.
for giving us another chance to follow your steps and our rules. We really need your help
To
find the formula of the solution. God, life is also a graph.
We don't know where the vertex is.
Because without you, we are nothing. God,
We extract our negative points by subtracting. We add or even multiply
our positive too. We graph the good things we have into others. God, please forgive me for sometimes being emotional, being dependent on the material things. But God, I try to be independent. Because as your child, we want to be a factors in your plan here on earth. Amen.
all together. The
Holy Cross of Davao College is a community of Christ-centered evangelizers, educated in the faith and animated by passion for truth, justice, peace, and service. As members of this Filipino Archdiocesan educational institution, we commit ourselves to promote quality Catholic education to all, especially the less fortunate, and to create through dialogue a Christian environment for the integral formation of persons who will be effective agents of social transformation.
So for now, may we request everybody to please go to your respective groups ng Prismatics. Please form your groups at the back. Yes. Tanan.
If you're if you belong to the group Prism, then form a circle. If you belong to the group Pyramid, form a circle. Cylinder.
And please move backward.
Please form a circle.
NUXML.
Pyramid. 4,000 lumang. Pyramid.
So where are the prismatics? Woo! And how about the spirits? Selendrinas, may I hear your voice? How about pyramid? How
Now we
are you?
direct.
What's the prismatics? Okay. I have one. 2.5 na siya. And spirit? So let us witness an entertaining number from the group Barbecue.
Andito na ang grupo na sikat.
Sino sikat?
Barbecue!
Again,
Barbecue!
Pakibolok, barbecue!
pakisigaw,
Barbecue! Sino tayo?
Barbecue!
Barbecue! Awu! Awu! Barbecue! Awu! Awu! Barbecue!
Oh my God.
And this time, may we lend our ears for the lecture of the ever beautiful, young, and sexy. Please help me welcome our first speaker, Miss Francella Baya. Let's give her a round of applause, please.
Oh my goodness, I did not expect it. But you are calling me beautiful, right?
Yes.
Of course it is. Of course I am, I should say. So, let's start our lecture for today, entitled The First Awakening, Fibonacci. Next. Of course, reported by us. So let's see the timeline. On the 5th to 11th century, often called the Dark Ages, or marked as the low ebb of mathematics. So, do you have any idea why is it called as the Dark Ages in that 5th to 11th century? Anyone? Anyone from there? Yes. May I hear your voice?
Murag ka rin mo, dira tayo diri kay katong science, kay murag ipagbawal na mag-discover something more because na Dark Ages.
Oh, yes. There's a point. So, a point from
Pyramid!
So, it is called as the Dark Ages because sciences and philosophy is banned, as he said. And that time, the people during that time has a little to no knowledge about those sciences, mathematics, and etc. That is why it is called as the Dark Ages. And it is mentioned there that it is marked the low ebb of mathematics. So when we say low ebb of the mathematics, it is the decline of mathematics. So during the 6th century, persisted Roman culture and Latin language was still in use in certain places such as southern Gaul and Italy. Next. So in the 7th century, Christian church became the sole custodian of intellectual life, preserving the cloister of few monasteries. Monastery school is an ideal center of learning. The essential aim of the school was to produce ecclesiastical leaders. They taught within boundaries fixed by the church interests and doctrines, the bare elements of the reading and writing, rudimentary Latin, and summary explanation of biblical texts. So, during the 7th century, the church only teaches the people about the church itself, about the biblical text, wherein there is no science and mathematics as mentioned before. So they taught only rudimentary Latin, the basic Latin, so that they can communicate with each other, and the summary explanation of the biblical text. So during that time, it is Christianity, the religion is Christianity. Next. revival of learning, or described as Carolingian Renaissance. So why is it called as Carolingian Renaissance? So its origin and focus at the court of the Frankish King Charles Magnet. So next. So, wala pa rin. So this Carolingian Renaissance was during the time of the Frankish King Charlemagne. And there is a story here that goes, on Christmas Day of 800, while Charlemagne was kneeling in prayer at St. Peter's, the Pope suddenly placed on his head the golden crown and hailed him as the Holy Roman Emperor. The acclamation was well deserved, for Charlemagne was not only the most powerful ruler in Europe. For all practical purposes, he was the only ruler. His dominion encompassed what is now France, Western Germany, part of Austria, and Italy as far south as Rome. So this revival of learning, so medyo nag-rise na ang mathematics and science because of Frankish King Charlemagne. So how? Next. How is that? Next one. Next one. So, Alcuin of York, he became the King Charlemagne's advisor. He is an Englishman, educated Englishman. So, he educated not only King Charlemagne, but most of the people of King Charlemagne. He ordered that every monastery school should have the 7 liberal parts divided into quadrivium. So quadrivium has the 4 subjects: arithmetic, geometry, astronomy, and music. And also, the trivium is the grammar, rhetoric, and logic. This trivium, we already discussed that during our 2nd semester. Do you remember our Filipino 101? About the trivium, grammar, which is the grammar, rhetoric, and logic. You're not listening to Momentuma before, right? No. So this, he ordered that every monastery school. So it is not only about the Christian life, which is being teach to the people, but also the quadrivium and the trivium. Next. So the Carolingian minuscule is created by Alcuin, form of writing with rounded, well-proportioned, and perfectly legible script, easy to read and write. And he also, one of his work also is the proposition for sharpening youthful minds, wherein he presented 53 puzzles of arithmetic. So, through this, the people during that time had already, the knowledge of the people during that time had already rise. So until 10th to 11th century, Arab met the ideas of Aristotle, Archimedes, and Ptolemy. All the texts of Greek science and mathematics are available in Arabic copies, like Euclid's Elements and Ptolemy's Megal Syntaxis, or what we call the Almagest. Next. So on the 12th century, Gerard of Cremona produced Latin version. Fewer than 90 versions were complete. So let's proceed to the 2 pioneer translators. So they translated those Arabic into Latin. Those Arabic words into Latin. First is Gerard of Cremona, who lived between 1114 to 1187. So he made known in the he's known in the second half of the 12th century. So how? He learned Arabic from a Christian translator, and So that's why he is known on the second half of the 12th century. He produced a Latin version of Ptolemy's Almagest, probably the New Arabic numerals. He also produced Latin versions of no fewer than 90 complete Arabic texts, as mentioned earlier. So among those 90 complete Arabic texts are Archimedes' measurement of circle, Apollonius' conic section, and Al-Khwarizmi's works on algebra. So the second pioneer translator is Adelard of Bath, who lived between 1090 to 1150. So he disguised himself as a Mohammedan student and attended lectures at Cordoba. Gained a copy of Euclid's Elements, which later he translated. And in this way, he made the geometry of the great Alexandria known for the first time in the Latin West. So he translated that the work of Alexandria about the geometry into Latin West. So now let's proceed to the Fibonacci and the Fibonacci sequence. So who is Fibonacci? Do you know another name for him? Yes? Yes, Salandrinus. Leonardo. Of course. He is Leonardo of Pisa because he came from Pisa, or he is also called Leonardo of Pisano. So born in Pisa about 1175 and educated in North Africa. He is also known as Fibonacci, the greatest mathematician in the Middle Ages. So, as a young boy, Fibonacci traveled with his father to help. It was there he learned the Indo-Arabic numeral system. And Fibonacci became the unamicable guest of the Emperor Frederick II, who enjoyed mathematics and science. And returned to Pisa in 1202 and wrote the famous Liber Abachdi. So, back. During the reign of the Emperor Frederick II of the Norman Kingdom of Sicily, Fibonacci was invited to the emperor's court to participate in a mathematical tournament. So, he answered 3 mathematical questions that his co-mathematician don't know how to answer it. And the emperor was greatly impressed by Fibonacci and his mathematical abilities. Thus, there is a statue of him in the garden across the river Arno by the Leaning Tower of Pisa. So here are the 3 questions he answered. First problem. Find a rational number x so that the quadratic expression x squared minus 5 and its x squared plus 5 represents a square of a rational number. So here is his solution. So his answer, he came up with an answer of 412. Since x squared minus 5 is equal to 41 minus 12, the quantity 41 minus 12 squared minus 5 and x squared plus 5 is equal to the quantity 41 over 12 squared plus 5. And it is equal also to 49, the quantity 49 minus 12 squared. So if you read this is his solution for it. So this solution was later published in his book Liber Quadratorum. On his second problem, he determined a root of the cubic equation x cubed plus 2x squared plus 10x minus 20 is equal to 0. And the third problem, it states that three men possess a pile of money, their shares being 1/2, 1/3, and 1/6. Each man takes some money from the pile until nothing is left. The first man returns 1/2 of what he took, the second 1/3, and the third 1/6. When the total soul return is divided equally among the men, it is found that each then possesses what he is entitled to. How much money was in the original pile, and how much did each man take from that pile? So in his second problem, he found out that no root of the equation can be formed in an irrational number. So he derived a decimal number, which is 1.368808. The solution was published in his book, Flaws. And the third solution is that it is published in the Liber Quadratorum. So for the works of Fibonacci, pin your ears back because Miss Bernadette Baluran will now take the floor. Let's give her a round of applause.
Hi guys, are you okay? Yes. So lend your ears because not tayo mag-games later. The works of Fibonacci. So these are the books na wherein he was famous in. First, the Liber Abaci, the Practica Geometrae, then the Flaws, and the Liber Quadratorum. First is the Practica Geometrae. It contains a large collection of geometry problems arranged into 8 chapters with theorems based on Euclid's elements and on divisions. So this book was it contained theorems based on Euclid's elements and on the divisions. It also includes a chapter on how to calculate the height of tall objects using similar triangles and calculation of the sides of the pentagon. So how many sides does the pentagon have? 5. That's right. And the decagon from the diameter of circumscribed and inscribed circles. So that book contains of this information. The next book is the Flaws. So you remember a while ago that Miss Francela Baya mentioned about the Flaws. It contains 3 of the problems that were solved by Fibonacci. Because he was challenged by the Holy Roman Emperor Frederick II. And because of that, because he answered the 3 problems that the other mathematicians don't know how, he was the famous one in his time. In one, he approximates the solution to 10x plus 2x squared plus x cubed is equal to 20 to 9 decimal places. So yun yung x is equals to yung decimal places na gimension ni Francel. Dahil dito nakabuo siya na yung 9 decimal places. So next book is the Liber of Abaci. This book is contained of Book of Counting. It is also called the Book of Calculation. This is the most important book of mathematics in the Middle Ages because it explains the virtues of the number system. So it is very important. Thus, introducing Arabic numerals and method throughout the Europe. These are the numbers we still use for today. numbers? Indo-Arabic. So the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yun, yung Indo-Arabic numbers na i-translate yan siya sa mga Hindu-Arabic na mga the way they write. So, para sa atin, yun yung 0, 1 to 9. Yun yung mga numbers. It also composed of almost all the arithmetical knowledge of his time. So, this book is very important. Kaya dito nakalagay yung the origin of the Hindu-Arabic numerals and all the arithmetical knowledge of his time. So, let's dwell on the theory of the origin of Hindu-Arabic system. So, theory, we all know na it needs, kailangan pa siya i-prove. But, as we read the book, in 3rd century before Christ, earliest preserved examples, so we are talking about the Hindu-Arabic system. Earliest preserved examples is found in record cut on the walls of a cave in a hill called Nanagat near Mumbai. So the example of the Hindu-Arabic system was found on the walls of a cave. Next, if correctly interpreted, these include, so in this 3rd century BC, ito yung nakita nila na but theory lang ito ha. The 1, 2, 4, 6, 7, 9. Yun pa lang yung na-translate nila itong Arabic writing. Another is the Brahmi, which is in 2nd century. So, a theory. It appears in carved inscriptions at Nasik, India. Remember, in 3rd century BC, it was found in the walls of a cave. But in 2nd century, as theory, it appears in carved inscriptions at Nasik, India. These Brahmi numerals of the 2nd century after that, so this time form a ciphered system with the following 9 symbols. 9 symbols. These are the 9 symbols. The 1, 2, 3, 4, 5, 6, 7, 8, 9. On the 3rd century, 1, 2, 4, 6, 7, 9 lang yung nandoon. But in this, 1 to 9. These are the Arabic writings nila sa Then, next, 0 underwent changes from near that to a small. Devanagari, in 8th century na naman, Devanagari, it means sacred. Numerals and characters are shown as this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Pinali karon? Yes. In 24, until now, these Arabic writings were still in use. So what is the history of Hindu-Arabic numerals? So Hindu-Arabic numerals from 0 to 9. Hindu-Arabic number is a number system that consists of numbers from 0 to 9. Arabic numerals originally came from India. So it originally came from India. Form is a system originally developed by a number Brahmi Indian mathematician named Al-Binuri. So Al-Binuri is an Brahmi Indian mathematician around year 300 before Christ. Brahmi numerals are not familiar with the number 0, the number 10, 20, 30, 100, 1000, etc. Figures Brahmi description found in caves and templates. So ang Brahmi is katong excluded pa ang 0. ano na siya, Arabic numerals, so na-include na ang 0 until 9. So, naman yung mga theory nga until na-develop siya ang numerals. So, what is the reason why they are commonly known as Arabic numerals? The reason they are commonly known as Arabic numerals in Europe and the America is that they were introduced to Europe in the 10th century. And who introduced these Arabic numerals? It is Fibonacci. Siya ang nag-introduce sa Europe. That's why Leonardo Fibonacci was the first European to use Arabic numerals in his book, Liber Abbasi. He was the first to use the Arabic numerals in his book. Hindu-Arabic numeral system is the most widely used today. So, makaroon na to, ginagamit ito sa mga Muslim. And kita po, ang numerals. This system has 10 symbols. So, kanto. The selection of 10 numbers is influenced by the number of all fingers is 10. So, 0 to 9 siya. 10 siya ka numbers because we have 10 fingers. So, dito siya gi-influence. So, next. Another theory, West Arab Gobar in 10th century. This primitive form appeared in the 10th century edition of Boethius geometry. So, nanapod siya another representation na po sa Arabic numerals. So, amazing kayo kag gina-develop nilang maayo. And then, next, the last one is in the Spain. 976. It is the oldest dated European manuscript known to contain the Hindu-Arabic numerals. So, the oldest dated European manuscript is named the Codex Vigilanus. So, nandoon siya sa Spain. The next book is the Liber Quadraturum. So this book is contained of book of squares devoted to the Diophantine equations of second degree, and Diophantine became interested in solving higher degree polynomial equations. Another person na involved kay Fibonacci, si Jordanus de Nemore. He is a contemporary of Fibonacci, known only by few works that had been found. The largest and most original of Jordanus' works is the De Triangulus and De Numeris Datis. So these are the books na known siya. What is the De Numeris Datis? Max? It is a text on advanced algebra that complements the Arabic treatises of Al-Khwarizmi and Abu Kamil. So Al-Khwarizmi and Abu Kamil. It composed of 115 problems divided into 4 books, offering a development of quadratic, simultaneous, and proportional equation. So the Numeris Datis is a book na composed of 115 problems. Next, the Numeris Datis, also the format consists of, this book has a format. First, a formal statement of the problem, a proof, and a specific numerical illustration. The next is the Fibonacci sequence. So, kagi naman kita Math 101. What is the Fibonacci sequence? Anyone? As far as you remember.
1, 2, 1, 1, 2, 3, 4, 5,
Sequence of numbers that is big higher than the previous number.
Yes, the Fibonacci sequence is the series of numbers. The next number is found by adding up the two numbers before it. So, I have here a video. So, the rabbit problem. Mangilaw kanina sa akin. So, yun lang tapos.
Jason Marshall here with a
Ganun po yung boss.
solution to Fibonacci's rabbit problem from Matthew episode 16. Here's Fibonacci's question. If two newborn rabbits are placed in a pen, how many rabbits will the pen contain after 1 year? To answer his question, Fibonacci wanted us to assume that rabbits always produce one male and one female offspring, that they can reproduce once per month, that they can start to reproduce when they are 1 month old, and that rabbits never die. That's the question. What's the solution? Well, let's think in terms of how many pairs of rabbits are in the pen at the beginning of each month, starting with the one newborn pair in the pen at the beginning of the first month. These newborns are too young to reproduce, so we begin the second month with one pair as well. It's the same pair, but they're now adults that are mature enough to mate. As a result, one new pair of rabbits is born at the end of the second month. So at the beginning of the third month, we have a total of 2 pairs. The original pair again mates at the beginning of that month, but the newborn pair does not. The original pair produces another pair of offspring. So at the beginning of the fourth month, we have a total of 3 pairs of rabbits. The original pair, their newest offspring, and their first pair of offspring, which are now adults. 2 pairs can now mate, and they each produce yet another new pair, giving a total of 5 pairs at the beginning of the 5th month. Now, 3 pairs can mate, so after the 3 new pairs of offspring are born, our total moves to 8 pairs. At this point, the sequence is 1, 1, 2, 3, 5, 8. What's the pattern? The trick is that each number in the Fibonacci sequence is obtained by adding together the previous 2. 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and 3 plus 5 equals 8. You can keep going and going on like this to find subsequent numbers, and after 12 months, you'll get 144 pairs of rabbits. In other words, the 12th Fibonacci number is 144. But is that how many pairs the rabbit pen would actually contain after 1 year? No. That's the number of pairs in the pen at the beginning of the 12th month, not the end. So we actually need the number of pairs at the beginning of the 13th month, which is 233 pairs, or 466 rabbits. But how does that compare to the exponential growth of the model where rabbit populations grow like a geometric sequence? The difference is huge. If the rabbit population grew like a geometric sequence and doubled every month, at the end of a year, there'd be 8,192 rabbits. And that's the story of Fibonacci and his rabbits. Until next time, this is Jason Marshall with this week's Math Dude Video Extra. Thanks for watching, math fans.
So, you understand the video, right, about the Fibonacci sequence and the difference between the Fibonacci sequence and the geometric sequence. And now, let's call it the Master of Ceremony.
Thank you for our lovely speakers. Now, we are done to 2, and 3 more to go. Before we continue the reportings, let's have an icebreaker. So, please put your seat and may we request everybody to stand up and come here at the center, please.
Sigawan pagpunod.
Ay, dala na yan. Meron na sayaw.
So, ayun, kabalungan mo atong ano no.
So form a line at the middle, please.
Mathematics Dance Challenge.
Let's share, we're running out of time.
One, sige na
Share lang, man.
So, wala na katulungan guys. So, andam na paminaw sa itong next portion.
So base here now, because at this juncture, Miss Monica Arandola will now deliver her talk.
I will tackle about the history of sine, cosine, and tangent. Sige lang pala yun. So where does term trigonometry come from? We already know about the trigonometry come from Greek words trigonon meaning triangle and metria meaning measure. So the word literally means triangle measurement. Sine, cosine, tangent is the main function of the trigonometry and are based on a right angle triangle. So sine, cosine, and tangent again date back to the Greek. So sine come from the Latin sinus, meaning a bend or the bottom of a garment. So this is the bottom of a garment and this is the bottom. So sine was originally applied to the line segment CD and the figure. Half the chord of twice the angle AOB. So before the sine derived or discovered, it is a chord because ancient Greek they did not have a sine function. They only have a chord as trigonometric function. So in Indian mathematics, a mathematician, they later on they discovered another term chord. So our Aryabhata, the mathematician in Indian, he is the one who introduced science. He made half of the chord and so half the chord of twice the angle, that is that solution or that is Aryabhata made so that he discovered the sign that we call lake. Then sign function is commonly used to model periodic phenomena such as sounds and light waves, the position velocity of harmonic oscillators, sunlight intensity and day length, and average temperature variation throughout the year.
Cosine was originally written co and sine, short for complement. Sinus. The sine of the complement, the cosine of the angle AOB is the sine of the complementary angle ABO in the figure. Likewise, cotangent and cosecant are the tangent and secant respectively of the complementary angle. The cosine of an angle is defined as the sine of the complementary angle. So, Mr. Suhaiber, what is complementary angle?
So, complementary angle, if you add two angles, is equals to 90 degrees. So,
Yes.
okay.
Complementary angle is a total of 90 degrees. So, the complementary angle equals the given angle subtracted from a right angle. For instance, if the angle is 45 degrees, given a 45 degrees, then its complement is
45.
yes, 45 degrees kay total of 90 degrees man siya. So, generally, for any angle theta, cosine theta equals sine 90 degrees minus theta. So, cosine theta equals 45 man tong given, no? So, sine 90 degrees minus 45 degrees. So, sine 45 degrees. Now, right triangle AOB. So, right triangle. So, Mr. Subing,
Dalam, ha? Isa, ha? Sige, hanap ko isa.
ay wala ko makunakuman. Ay wala ko makunakuman.
Sequence, 1, 2, 3.
So, pila man ang Mr. Subing, pila ang measure sa right triangle?
90 degrees.
Ako nakuman na.
Right triangle.
Right triangle!
Right triangle.
Yes.
Ang 180 degrees. Tapos
Yes.
yung angle is
180 degrees. So, ang kini siya is, ano na ni siya? 90 degrees.
serious, ang good.
Wait, ano guys? Na wrong, na wrong. A or B. So, diri amo ni ang 90 degrees. So, since the sum of the angles in a triangle is equals to 180 degrees, and the angle A is 90 degrees, that means angle O and B add up to 90 degrees kay, di ba 90 degrees tapos add mong A o B kay 90 degrees po ni siya. So, mag-total na siya of 180 degrees. So, cosine theta cosine pila man ang value sa pi? 180. Divide 2 minus 8. Cosine theta equals sine 45 degrees. So, Mr. Manabat will well then deliver his lecture about the tangent function.
Tangent comes from the Latin tangents, represent participle of tangere, to touch. In other words, which means touching was originally. Then, applied to the line segment AB in the figure, the segment of the tangent to the circle at A that is cut off by extension of OB. The ratio of the tangent AB to the radius of the circles OA is the tangent of angle AOB. As it passes through the point where the tangent line and the curve meet called the point of tangent C. The tangent line is going to the same direction as the curve and is thus the best straight line approximation to the curve at the point. Similarly, the tangent plane to the surface at a given point is the plane that just touched the surface at the point. The concept of tangent is one of the most fundamental notions in differential geometry, has been extensively generalized in tangent space. The word tangent comes from the Latin. This is the example.
Ay, tangent into tangent. Okay, 1 so 1 common point. Ito, hindi ka na tangent pa rin
So, we can see in here that this is the tangent where it touches the point at exactly, it touches the circumference of a circle at exactly 1 point. And that is the sine and the cosine and the versine, x second, x cosecant, and more. Because this x second, x cosecant, and more was already discussed yesterday. So that's
So the mathematicians, Aryabhata, he was the first of the major mathematicians and mathematicians and astronomers from the classical age of Indian mathematics and Indian astronomy. He discovered the sine and cosine.
another one is Muhammad Ibn Musa al-Khwarizmi. He discovered the Tanjan, a related treatise on spherical trigonometry is also attributed to him. Next, Albert Gerard. He was the first to use the abbreviations sine or which will be abbreviated in sin, the cosine, cos, and the tangent, tan. The three trigonometric functions. These are the sine, cos, and tangents are things that are done to angles, not sides. So, dili siya sa side but in the angle. The important angle of the problem is called theta. So, theta reminds me of an eyeball and that helps me remember that the angle theta is the angle that the situation is viewed from. So, that's
So,
it.
let's give a round of applause. Now, let us be amazed by an spectacular, extraordinary performance from the Barrio. Give a big hand to the group barbecue.
This math rap is entitled Try Math. 1, 2, 3,
Sa'yo
go.
daw taong
This
ma-is na
math
dapat
to
or
win,
7:30 na dapat dali ka sa eskwelahan.
to conquer, to try with math to win, to survive, to prosper, to rise, to One, two, three, go. I wish a day that. One, two, three, go. I wish a day I learn that every day. Maybe that will make everything okay. Trying to be the best version of me. Trying, but I can feel a mile away. A mile away? Yeah, in a way. Maybe that is why I chase numbers away. They get attention. I can't solve immediately. But they're just numbers. And I am me. Me against them. Me against geometry. Me against that. A city full of integers. Leave us up. They start coming. And we start writing. Let's be writing. We're calculating. We soar higher. 1, 2, 3, go. It's not too easy. To try to conquer. To try is not to win. To survive. To prosper. To rise. You Everybody wanna try to back me in. Suffocating every time it locks me in. Admitting that it's hard, but we used to stand. Cause it's the only solution to every problem. It's Get ready for it. Just try to solve it. With mathematics, we come to win. We come to win. Try that is our rap.
Spectacular, isn't it? So now let's move to another presentation, which is the math poem entitled Math is Fun.
Math is life. We can use formulation. We should apply the equation. On the negative side, we should apply the subtraction. And on the positive side, we should apply the multiplication. To be a joyful one, multiply the fun. On the sorrow's side, don't run. Just subtract the unhappy one. Math can always be related to our lives. Full of fun, with so much to learn. It teaches us to always be careful with the signs. Math is life, we use it in our life.
So we still have time, but
We're not done yet. So before we end our group presentation, we will be having an activity. It is called a prank quiz. But this kind of game will be giving a prizes. The back of your under your armchair, there is the number. We put it there. So we will so if wala yung number inyong bangko, pangita ko na yung number because the prizes are very amazing. So the first, okay, listen first. Well, you can okay. Number 10. Who got the number 10? Yeah. So there is a night question. So kung maka-answer mo, na may prize. Kung dili mo maka-answer, kung dili mo maka-answer, it's a minus. Either musayo mo or mukanta or ma-less inyong score sa quiz. So, this is the test na naminaw gid mo ganiha kay naningkamot gid ang reporter nga ma-report ang dapat i-report. So number 19.
19 daw. Be honest guys, daliin ninyo kayo.
Number 21.
Oh, wala.
21.
Wala yung matagwas. Number 35. So, kinsay mo ano na lang kanang Number 20.
20.
Daga na gid mi ano. Sige na for sure. Ano lang
Be honest mo.
Sige, so okay, number 2.
Ako ka na, di number ko. Wala ka
Number 2. Ay, hindi mamunot mo yung freedom.
Ay, Julie.
In other words, it means touching. So, ano yan? Siya ang nakaansan sa to. In other words, it means touching. Bakit nag-price? Yes, I will start naman. Baka yung pinag-price. Kung di ka answer in 1,
Tangerine.
Huh?
Tangerine.
No!
Tangerine.
Yes!
Tangerine ito.
Isa na lang.
Or Tangerine.
Tangerine.
Asha or Tangerine.
Tangerine.
Or Manto.
Hoy, tangent kayo. Ayan. So, your prize will be a ballpen.
Hoy, dapat. Pilot.
Number 5.
Pwede ba dapat masayaw siya?
Okay, ikaw. Umakas ako sayaw. What? Kung dili siya kabalik answer, what is the name of the school described as the ideal center of learning? Ano to? Ideal center of learning. Name of the school. In one. Oh, still. Ano lang bisa ng taas. One. Okay, kinsay mo. Still.
School, right?
Raise your right hand. Dili na mo tawagan ang tao nga ka ng sabak kayo. Dapat dili nyo ng answer tayo. So, now we prize aning it consists of 2 prizes. Sige. It is the most important book of mathematics in the Middle Ages, or it is a book of counting. It is a book of counting. Raise your right hand. Raise your right hand. Bern, ayaw mo na ka.
Hoy.
The book of calculation.
No?
Oh.
Mga book yun.
Hoy, po manata.
Lever of Abachi.
The liver of
Abasi.
So, congratulations! So, na-assign duha ka prize. Dahil biscuit.
Ay. Mga kuripot alag nakadawat og 60k ay.
Another question. It consists of 3 prizes. So, the question. He was born in Pisa and educated in North Africa.
Leonardo.
Okay.
Correct! Lishu and Lopez. Congratulations!
Pansit Canton.
Another one! The most exciting. We have 5 prizes. Wow!
Ay, 5 Bonacci.
Question.
5 Bonacci naman.
Napay 124.
Give at least 2 words of Fibonacci. Give at least 2 words of Fibonacci. Oh, sige, be.
Liver Abasi of plus.
Liver Abasi.
Abasi.
Liver of Abasi.
Pwede po liver kwadrato mo, ha?
Okay. Congratulations.
Hoy, sila ko niyo prize. Prize dahil.
Patry tayo yan.
Yellow paper.
Uy, magamit din sa crazy mo.
Another one. 8 prizes.
8 kas number.
5 Bonacci na dyan na.
Kita mo muna.
Question. He produced a Latin version of Ptolemy's Almagest, probably with the new Arabic numerals.
Leonardo,
He produced a Latin version of Ptolemy's Almagest, probably with the new
Di man jud tanan makapi na to ilang gidiscuss mo dapat matay ko ano. Answer it.
Sige, answer me.
Para sa
Next.
So,
13 prizes. Kung sa kaya ni. Prizes. Pag wala ka sweaty na sige. It comes from the Latin word sinus, meaning a bend or slope, or the bosom of Lahaya. Correct.
Minto, salamat! Salamat!
13 kamintus.
Gamit kayo sa meeting niya, ba? Salamat kayo, ha?
21 pieces of prizes. Ay, wala. Oh, nanay ha. This was described as Book of Squares.
Ako eh.
Yes.
Quad. Liber quadratorum. Kailan siya man to? Liber quadratorum.
Correct!
Sunod.
Naka-receive ka!
Salamat. Uy, dapat maka-learn mo sa kwan word na appreciation.
Yay, aya.
Yes, kasi na-appreciate ko. The final question.
Fibonacci na.
Ano ang natin ito mo? These are willing mo answer. Itaas mo. Wala, dili pa na kayo ng question.
By pair, by pair.
Isa lang.
By pair.
By group. Isa lang yun.
Ay, kala lang yung question.
Isa lang. Ito yung gusto yun. Okay lang, ganito. Isa lang. Sige, go. Wala ka ba?
Wala.
Mana. Ay, ako daw.
Isiyaw na sa
Gusto mo na, uy, tig-video lang ko na rin. Ay, tao.
Ay, wala na ako eh. Intern na na.
In this
Pigod to nun.
pieces of prizes, what have you, ilong lang mo ha, wala dyan answer. What have you observed?
It's a Fibonacci sequence.
Congratulations!
Uy, tao. Uy! Uy, wala mo yatag sa ako, ah.
To end our presentation, so the game is connected in Fibonacci sequence. The prizes itself is the Fibonacci sequence. So thank you for participating.
Thank you. Salamat. Salamat.
Okay, next. The following are the words of Fibonacci, except A plus B matrical geometry, C the numerous reductions or D Liber abaci. A plus B practical geometry, C the numerous reductions or D Liber abaci. 4. The symbols 1, 2, 3, 4, 5, 6, and so on are known as A. Roman numerals, B. Indo-Arabic numerals, C. Sexagesimal number system, or D. Hieroglyphics. 5. Which trigonometric function is not seen in scientific calculator? A. Tan, B. Cosecant, C. Sin, D. Cosecant. Ay, cosine. So for test 2, you have to name the mathematician. So here are the choices: Leonardo of Pisa, Alcuin of York, Jordanus de Nemorin, Albert Berard, and Ariel Patel. So number 1, he worked on propositions for sharpening youthful minds, which presented 53 puzzles in arithmetic. Number 2, he discovered sine and cosine. Sine and so you have to be careful with the spelling, wrong spelling wrong. So, are you done? So let me read the question. He worked on, number 1, he worked on propositions for sharpening youthful minds, which presented 53 puzzles in arithmetic. Number 2, he discovered sine and cosine. Number 3, known because of his work Fibonacci sequence. Number 4, his largest and most original work is the De Numeris Dandis. And number 5, he was the first to use the abbreviation sine, cosine, and tan, or sin, cos, tan. So for test 3, we have matching type. So just like write the letter on after the number. Also your numbering, follow the numbers.
First ang letter of the number.
Okay, kaya na. 1 to 10 nga pag dili siya sunod i-direction.
Kuha na ka straight ba?
Ay, straight na ninyo.
Straight na with number.
Sige na.
Number.
Letter. Ano ba? Dili nag-i-separate.
Separate.
Separate 1 to 3. Ay, ano, kana. comes from the Latin word complementi sinus. Number 5, also known as book of squares. Number 6, also known as Devanagari. Number 7, Fibonacci sequence. And number 8, revival of learning. Number 9, book of counting. And number 10, the discoverer of sine and cosine. You're not just quiet. So number 4, for the last part, is more not last part na din. Fill in the blanks. So complete this Fibonacci sequence.
Yun ba?
Sana na mga blank.
Sunod-sunod na.
Ano niya?
Balik na siya kaano.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
That's na ako.
You can use calculator. Yung 5 minutes to answer this. Are you done?
Oh, kumain na.
Kuya, number ninyo, ayaw ka lang
Manabatin